Hi, I'm Purmini from 2nd BComC.
I'm going to explain about transportation problem. In simple words, transportation problem is a special kind of linear programming problem technique in which goods are transported from a source to a set of destination according to the supply and demand, the source and destination respectively, such the total cost of transportation is minimized. In balanced transportation problem, we are going to see northwest corner method.
First step, what we have to do is we have to check whether the sum of demand and supply are equal separately. Adding supply 4, 8, and 9, we are getting 21. Adding demand 3, 3, 4, 5, 6, we are getting 21. If both demand and supply are equal, then it is known as balanced transportation problem. This is the first step we have to check in every sum. Now let's move on to the step 2.
Well, after checking the first step whether the given table is balanced transportation problem, then we can move on to step 2. In northwest corner method, we have to start from this box, like seeing which number is the least. So we can find 3 is the least number, so we are going to place it over here, strike 3 and the entire column. And now we are going to subtract 3 from 4, we get 1. After doing this, we are moving on to the next box. We can go this way because we have way over here, but if this box has striken out and even this box is striken out, then we have no other go, we can go this way. But as we have way in this side, we have to do our next step in this box. So again, we are going to check which one is the least, 1 or 3. 1 is the least number, so we are going to place it, strike 1 and the entire row. And the next one is we have to subtract 1 with 3, we get 2. Then moving on to this box, we have to check the same least number, that is 2, strike the column, subtract it with 2, we get 6. Moving on to this box, which one is the least, that is 4, strike out 4 and the column, subtract 6 with 4, we get 2. And then moving on to this box, as we have this way, check which one is the least, that is 2, strike 2 in the entire row, subtract 5 with 2, we get 3. Moving on to this box, as we have striken this box, we have no other go, we have to go this way. Check which one is the least, that is 3. So, strike out 3, strike out 9, like minusing with it, we get 6. So, the remaining number we have is 6. After doing all these steps, we have to check whether this sum is non-degenerate feasible solution or degenerate feasible solution. So, first we have to satisfy this formula, that is m plus n minus 1. M is considered as number of rows, n is considered as number of columns. The number of rows are 1, 2, 3, and the number of columns are 1, 2, 3, 4, 5, minus 1. When we calculate, we get 7. So we get 7, and now we have to check how much number of allocations we made. The independent allocations are 1, 2, 3, 4, 5, 6, 7. So the allocation we made is 7, and the formula we satisfied is 7. As the both formula and the allocations are equal, this solution is considered as non-degenerate basic feasible solution. So to find the initial transportation cost, what we have to do is, first we have to take 2 into 3, write it down here, 2 into 3 plus 11 into 1, 11 into 1 plus 4 into 2 and 7 into 4 plus 2 into 2 plus 8 into 3 plus 12 into 6, so on. So this is how we have to write it down, and we have to calculate and we get the answer. So we have multiplied everything first individually, and we added all those values as we get the multiplication answer. We added all those values and we got 153. This is how we have to calculate transportation cost using northwest corner method.